Good afternoon, everyone. My name is Nathan Alexander. I'm an assistant professor of data science and education, and I want to thank you for choosing this breakout session. Today, I hope to walk you through some of the work that myself and my lab do around data science and its connection to mathematics. The presentation will walk us through a few things, but specifically, as you see from the title here, we'll focus on the cultural and historical aspects of data science and really think about ways that you, your students, and your colleagues might consider some different ways of approaching your data science practices. I'd like to also thank some of the funders for our work, the AUC Data Science Initiative and data.org. So the title of today's talk is Toward a Culturally Relevant and Historically Responsive Data Science. And so I'll walk you through a bit of our presentation. So first we'll talk really broadly about culture and history, and we'll look at the computational sciences and begin specifically with mathematics. We'll then think about what it means to be equity-minded in data science and how, when we're equity-minded, we might think internally about our own personal work, but also externally about the communities that are directly around us or related to the work that we might be interested in doing in data science. We'll then think through a few specific examples and case studies. And as we think about those examples, we'll add the layer of the historical component by thinking about the past. We'll also think about the present and do some visioning for the future. And then finally, we're going to think about what it might mean to think about culture and history in data science, but specifically beyond examples and case studies, but as a way of being, or what we're going to call a praxis. And so to really tie in the historical component, I'll have us begin with this image. And I'll give you just a few moments to consider who this person is, and if you've ever seen this photo, what it might mean in the context of the computational sciences. So for those that may not be aware, this is Albert Einstein, and he's actually on a visit in 1946 at a historically Black college in Pennsylvania known as Lincoln University. During this time, I want you to imagine what's happening in 1946 in the United States. And as you think about that, think about what it means for Albert Einstein, someone who we associate with high intelligence, physics, one of the greatest minds ever, to be pushing against contemporary constraints, and specifically contemporary constraints that are historical in nature and racial, sort of in relation to our identities. There's a quote there by Einstein in terms of how he was pushing against contemporary constraints during this visit in 1946. And as we go into the presentation today, I'd like for us to all use Einstein as an example about how we might think about data science, the computational sciences, as ways to push against contemporary constraints, both in the content that we use, but also in the ways that we use our bodies and decide to visit individuals or students or different organizations, and how we choose to partner across these lines. I'll also have us think about more broadly the meaning of mathematics and what mathematics can be for others. So I'd like to use these axioms from a colleague of mine, Federico Ardea. They were published in 2016, and these are really a set of 4 axioms that really give a call to how we can think about mathematics, as Dr. Ardea says. In his first axiom, he talks about how mathematical talent is distributed equally among different groups, irrespective of geographic, demographic, and economic boundaries. And so as we think about his axioms for mathematics, I invite us all to think about how math and data science, the math of data science, can also fit this axiom. In his second axiom, he talks about the fact that everyone can have joyful, meaningful, and empowering mathematical experiences. And so again, we want to extend this axiom to thinking about data science and how, despite its traditional meaning in the world, how data science can be used to allow people to have meaningful, empowering, and also joyful experiences. In the third axiom, which we'll focus on today, Dr. Ardea talks about how mathematics is a powerful tool. And in being a powerful tool, it's malleable and that it can be shaped and used by different communities to serve their needs. And so in a lot of our examples today, we'll sort of think about how data science is also powerful and malleable and how it can be shaped in a similar way to support communities and to learn about communities and service the needs of those communities. And finally, in the fourth axiom, Dr. Ardea talks about how everyone deserves to be treated with the dignity and respect. And so again, in the consideration of data science, we want to think about the extension there. And so through our time today, I'm going to take these axioms, and in particular axiom 3, to really think about the ways that data science, specifically from a historical and cultural perspective, can really become a malleable tool that we use in partnership with our students and community members. And so to think more about history, we'll begin sort of thinking about mathematics, both as a language, but also as an abstraction. And so I'll just give you a moment to read through these notes. And so one thing that we do know is that mathematics has a privilege in the school curriculum. And so mathematics sort of serves as a way to divide students, but also as a way to sort of segregate students in relation to perceived intellect. Beyond sort of those identity-based values, we can sort of think about mathematics as a language and how, as a shared language, it's not universal, but in the sense of it being something that's shared across cultures and communities across the world, and how these values and the symbolic meaning have sort of created this culture of mathematics. When we sort of think about it as a process and its extension, mathematics has been used in the computational sciences. It's sort of that language or that foundation that allows those sciences to connect. And so when we think about data science, we know that data science has a lot of those foundations. And so in mathematics, as we sort of think about idealization and abstraction, we also see a lot of those same practices in being enacted in data science. And so we want to sort of think about the ways that data science can support the future of students learning math and mathematical concepts in a way that's ideal, in a sense of how we might think of the oppressive ways that mathematics has been sort of enacted in the school curriculum versus sort of non-oppressive ways that we might desire in sort of a future sense. I point us to Charles Wade Mills, who sort of thinks about these things in particular to race and ethnicity, and how society has sort of been situated around these oppressive and non-oppressive society ways of thinking. And one way that we see those oppressions come out is sort of in the segregated way that we look at math classrooms. Who's allowed to learn math, who's allowed to engage in math, and even which schools have access to mathematics. When we go a bit deeper into these histories, we can sort of even think about some of the abstractions that have related to this culture of math and the lived reality. And so if we go pretty far back, sort of in a historical way, we can even think about the relationship between mathematics and religion and these utilitarian methods. And so mathematics in its sort of original forms from a utilitarian perspective and how it's shifted over the time to an abstract, formal academic sort of practice. And so we sort of think about this in the context of history. We can use Euclid's elements and sort of think about the role of geometry as one example. Now, given the history of math, we might question initially around the role of data science and how academicians specifically, as the individuals who will teach data science in these certain cases in post-secondary and secondary contexts, and how data science and its culture might be developed over time. And so I'll point us to an article that was published in 2020 in the Harvard Data Science Review by Rafael Iribarri, and it focuses on the role of academia in data science. And this article argues that data science is not simply a discipline, but rather an umbrella term. And so as we look at data science being an umbrella term, we sort of see the many complex processes. And as I think about these various entry points to data science and how students might not see similar entry points in mathematics, we might think about data science as a team-based activity. And as we think of it as a team-based activity, It sort of reminds us that there's a team working together and they have overlapping and complementary skills, as opposed to everyone being an expert across the board. From a curricular standpoint, we can think about some previous work that has been done as it relates to undergraduate data science programs. And so when we think a lot about the K-12 curriculum, what students will be doing in elementary, middle, or high school, considering some of the conversations happening in undergraduate education sort of allows us to build a way of thinking about a pipeline. So what does it mean to do data science in the context of a curriculum framing? And so in the Annual Review of Statistics and its Applications in a 2007 article, quite a few authors sort of look at the different guidelines for undergraduate programs in data science, and they posit a few different ways of thinking about what we might want to prioritize. And the first of those is really thinking about data science as a science. And so as it relates to sort of doing computation and computational thinking, as we sort of think about the scientific process, a well-ordered step of completing a task and finding different ways to answer different questions and inquiries. They also focus on the interdisciplinary nature of data science and how we can think about different fields being engaged in different disciplines. So again, sort of thinking about it as an umbrella term, how are there ways for us to think about data science beyond computation, but more so in partnership through a cross or interdisciplinary way of doing computational practices. Thirdly, they talk about data science in this recursive data cycle and sort of what that recursion means in relation to sort of learning and student practice. And then finally, they talk about the ways that we can think analytically, the mathematical foundations, and how mathematics and analytical thinking allow us to be flexible as it relates to the really different techniques that may not exist yet in terms of solving different global problems. And so what we find with these reviews and these articles is a real urgent need to cooperate and to collaborate across our different silos. And as we learn how to cooperate and collaborate, one opportunity for us is to really embed culture and history into these processes that really are responsive to a lot of the research that has been conducted in mathematics. And so for this next part of our time, I'm going to walk you through an article written by a few colleagues and I, and we're really going to think about some of the work that might be done, that might need to be done in data science as it relates to sort of this equity mindedness. And so really starting at this root of the problem when as it relates to data science and equity mindedness. And so this article written by my colleagues and I was published in the Journal of Humanistic Mathematics, and the title of the article is Beyond Ethics, Considerations for Centering Equity-Minded Data Science. And so part of our goal with this article was to really think across institutional types, across our own histories, and also across the different ways that we engage in data science. So we were effectively trying to understand the collaborative, cultural, historical nature of data science and how it might be enacted across different institutional spaces. And we asked ourselves quite a few questions around what this could mean. And so I'm going to invite you to join, maybe take notes or sort of answer these inquiries. There's a set of 5 questions that we asked throughout the article that I'll walk us through briefly to sort of help you think about what it might mean to center equity-mindedness in data science. And so that first question is related to positionality and our positionality specifically as it relates to our identities. And so the question that we ask are, what identities do you hold which inform your perspectives? And so outside of data science or math specifically, sort of thinking about who we are in essence as people, how do we define ourselves? Which identities do we attach ourselves to? And how do those identities generate our view of the world and ultimately the way that we might think about moving throughout that world? And as we decide on the ways that we move, a second question that we ask is related to the different journeys that we have had. And so as we sort of think about our positionality, our identities, the second question is, how did you come to do the work that you currently do? And as you continue to do this work in the context of equity-mindedness, sort of really positioning both what's within and beyond ethics. And so that was the main role of this article, was for us to really question, what does ethical practice mean within your context, but also with other communities? And one of the things that we found in sort of our explorations around ethics was a question about culture. And so when we move beyond ethics, we have to really engage these themes of the past, the present, and the future. And so a question was, how do you think about those periods of time and how they relate to your work? And finally, in our sort of review and analysis of different time periods, considering how we hold ourselves accountable and those around us. Maybe it's our family and friends and loved ones, but as it relates to a lot of the work that we're doing, our colleagues, the communities that we hold ourselves accountable to, our students, and our partners. And so, in doing sort of these practices of reflection and sort of thinking about our positionality, our journeys, ethics, culture, and accountability, we really sort of gain some understanding around the different ways that we take the world and make sense of the world using math and data science. And so, as we shift from this part of the presentation, I'll sort of talk about a broader frame of thinking about how we might model the world. And as we think about modeling, again, I'll depend on mathematics and sort of shift over to sort of thinking about data science. And so I'll first start with this basic figure here on mathematical modeling and how when we think about modeling broadly, what we're really doing is taking the real world, some phenomena in the real world, and placing it in this conceptual world. And this conceptual world contains these components of observations that we might have made from the real world, different analyses that are based on the models we developed, and any predictions that come as a result of those. So this becomes a cyclical process that we move ourselves through. And so one question that I have, and I invite you to join me, is sort of thinking about what would this process here look like in the context of data science? And so for our next part, I'll walk us through some examples and have us think across these three periods. And so we'll talk about the past, the present, and the future, and look at data science from a critical, cultural, and historical perspective, and sort of think about different examples that might have existed for us to leverage in our classrooms. So the example that we'll focus on is really focusing on this concept of land. And the easiest way for me to frame this is to think about this current practice of land acknowledgements. I'm sure that many of us have been on meetings where there has been time held during that meeting for land acknowledgement. And during this land acknowledgement, we're often sort of asked to sort of think about what land we're on, who are the sort of indigenous communities who are part of this land, and how we might keep them in mind. As it relates to data science, one question is sort of what's beyond the land acknowledgement. And so in our example today, in the case studies that we'll walk through, we'll sort of think about land as a grounding example. And for this first question with the past, we'll ask ourselves, what historical examples exist for us to examine this concept of the land as it might relate to data and data analyses? And so I'll bring us to this image here. I'll just give you a moment to think about what you see. And so what we have here is a graphic explaining the different lands that were claimed by indigenous tribes. And what we're going to do next, and sort of thinking about this historical component, is sort of travel throughout time and sort of watch what happens in a sort of a dynamic sense. And so we'll make our first stop in 1784. And a question that I will have you think about is what was happening in the world in 1784 and what was happening here in what's currently the United States in 1784. And then we'll move forward to 1820. Same questions. What was happening in the world in 1820 and what was happening in what's currently called the United States in 1820? And sort of think about its relationship to this image and the different lands that were claimed by indigenous tribes. And finally, we'll look at the present day. There are many entry points for us to think about culture and history in data science. And as it relates to data specifically, I'll fast forward us to think about census data, and I'll bring us to the current image. And so what we should see across these images, and I'll just go back to the previous image, So we have present day reservations held by indigenous communities. And then we have a graphic of census data from statisticalatlas.com as it relates to these various demographic information on the right-hand side there. And so this becomes an opportunity for us to connect the past as we sort of think about land and data science to sort of considerations around the present. And as you look at those different variables on the right-hand side of the image there, you might think about different things that could allow students to inquire or answer questions as they relate to these different dynamics that we saw in those images before. What a lot of this requires, though, is a radical shift in sort of how we think about practicing data science. And so generally, when we think about data science, we think about computation, formula. And so this practice now asks us to weave in culture and history as a means to just jumping into data. We're going to weave in the cultural and historical aspects to this data here, with the data being census data. And so part of what that requires, as I said, is a radical shift in sort of the paradigms of teaching and learning. And so I'll take a brief moment to have us think about historically where we've seen radical shifts in different fields of study. And so many people are familiar with the term germs and how germs are bad. I will say, though, there was once a theory, the miasma theory of bad air, that sort of was the leading paradigm as to how we thought about disease and germs. And so when we look all the way back in 1854, we can sort of see this happening with what Dr. John Snow did, who's considered one of the founding fathers of epidemiology, and sort of considering a radical shift in how we see things. And so part of the quest here is like, what would this look like in the field of mathematics and data science, where we're sort of making a radical shift to things that just seem normal or normative or correct, and how a slight shift in our thinking could actually result in a really different way of doing things. And so as we ask that question, we can come to the present and sort of think about these historical legacies. And so as we sort of think about these radical ways of being, radical ways of thinking, which are simply just getting to the root of something. So I'm quoting Audre Lorde there and sort of thinking about the root issues, sort of what those root issues are. And as we think about radical in that way, how do those root issues relate to the cultural and historical backgrounds of what we know? And so that second question that I'll ask is, how do we shift to radical formal models of injustice through the lens of data science? And so I'll begin by reminding us about the Keystone Pipeline and how indigenous communities, as a result of this pipeline in our present day, were fighting using data analysis, using various forms of knowledge to say that this is sacred land, this is land that has been stolen, and this is land that needs to be protected. We ultimately know that the pipeline was built and that the pipeline did burst and oil was spilled on the land. And so when we go back to the data that we have, census data, and when we use those historical examples, we're able to connect those to the present and really begin to think about, in partnership with our students and communities, how data from the past, how data about communities from the past, and how data about the present, so thinking about census data, can really be tied into one package to really think about this question of the present and shifting to radical forms and models that help us understand injustice. And there's a lot of data, a wealth of data as it relates to the Keystone Pipeline. I'm thinking about the company that was building the pipelines, the communities that were being affected, and also just the land that was being affected from an historical sense. And so as we work through these historical examples and as we see their connections to the present, it brings us to this question about the future and really sort of asking, as we do this work and as we seek to shift data science and mathematics and the computational aspects, really questioning about the collective futures that we seek and what do those look like. And so in closing, I'll have us think about a field of studies that's not often discussed, but it's future studies and speculative fiction. And what these fields of inquiry do is sort of really have us think about longer terms. And so most often in policy conversations, we might be talking about 1 to 5 years and sort of immediate outcomes. But in future studies, what we're really thinking about are these more expansive ranges. And so maybe 5 to 50 years or even 100 years. I would argue that as we sort of expand that time, it gives us an opportunity to really look back historically, sort of think about schools and schooling, data science, and different historical examples, and connecting those sort of through these participatory practices with students to sort of thinking about how we might envision the future. And as we envision the future, what is it that we need to do today to prepare ourselves and students for that? This also allows us to engage in different ways of knowing. And so really thinking about speculative fiction. And so in my lab, the quantitative histories workshop, we use a lot of different speculative notes and speculative fiction as a way to invite different ways of knowing and being into the conversation. I mean, what this really does for us, as you see in the last bullet here, is it keeps us action oriented. And our action orientations are really focused around these future processes and what might we contribute to the world today as a means to get to that point. And we do this process through a field known as Afrofuturism and a discipline. And what it does for us in our work is really take the role of race and how race has historically been a really dominant factor in how society has been structured and really connecting that to these future studies. And so if any of you have ever seen some of the work done by W.B. Du Bois, who did a lot of work in data science at the turn of the century in the early 1900s, we're really sort of building on a lot of that as it relates to this Afrofuturistic concept. More specifically, what we're doing is shifting our thinking outside of the academy. And so beyond data science being a way for students to learn how to code, a way for students to learn about different technical or computational features, what they're really doing is integrating these cultural and philosophical aesthetics of science and history into their practice. So Afrofuturism for us serves as a way to sort of engage music, art, writing, and different examples that allow us to really shift what we focus on in data science. And what this really brings me to towards the end here of my time with you is sort of the purpose of the breakout session is to have you think about what it means to do cultural and historical data science practices and really to develop a praxis or a way of being in your local setting. And so I'll walk you through a little bit of what we do in our local setting to sort of really think about what cultural and historical data science means for us and how we think about this as a lifelong process and practice as we sort of get towards a praxis as opposed to just individual examples that we might sparse through the curriculum. And so the first of those is critical education. So really gaining a serious understanding of history. And this provides opportunities again for us to work across disciplines and to work interdisciplinarily to think about data science and critical education. So we're talking about fields that are not very popular right now. And those fields actually are extending our ways of thinking from these more traditional ways of insight. So we have fields like Black studies and ethnic studies, women and gender studies, queer studies, and even disability studies. And so I encourage everyone to consider these fields of thought as they sort of think about ways to think culturally and historically about data science. You also want to think about quantitative research in the sciences broadly, and how these framings can be attached to those cultural and historical examples. And so we went through one with the census data, thinking about population and indigenous land, and the many insights that can come from modern examples like the Keystone Pipeline. And so in this way, it's sort of asking us to think more about applications of quantitative research in data science. And as we make those applications, we want to think about qualitative research and how that allows us to tell stories. And so thinking back to the example, how are those in the Keystone Pipeline affected? And what do those stories allow us to do to sort of bring our data to life? And how can we use that data and partner with communities to make sense of that? And finally, really using the cultural aesthetic to bring learning to life for students. And this really becomes a result of speculative fiction and Afrofuturism. And so how can art and design and other ways really engage students in different ways of learning computation? And so with that, I would say thank you for attending this session. I can be reached by email at nathan.alexander@howard.edu. Thank you.